Okay, this discussion is going to look at the way that we can write equations for chemical reactions that occur in aqueous solutions. So far we've been focusing on acid-base and precipitation reactions, and what we're going to look at is how do we focus in on the things in solution that are actually undergoing a chemical change, the things that are actually reacting. If we look at our example equation here, where we've got silver nitrate and potassium chloride, if we look here at our products, we see that silver chloride is formed and it is a precipitate. Remember, we talked previously about the fact that in order for there to be a chemical reaction, we have to be forming something that's going to remove these ions from the solution, whether it's, in this case, forming a precipitate, or it could be that we are creating a molecular substance, like in the acid-base reactions where we're actually making water molecules as a product. So these are the kinds of things that we're going to be focusing on, is just what ions are in solution that are reacting, and which things are a part of the solution but really are not undergoing any kind of reaction. So in this case, when we're looking at this reaction, the things that are actually participating in my reaction are the silver ions and the chloride ions. Okay, net ionic equations. In a net ionic equation, basically we're only going to show the species, and it could be ions, could be molecules that are actually reacting and that are actually formed. So this is a way to show exactly what's going on. We're going to have things that are called spectator ions, and these are ions that basically are not really involved in the process. They may be a part of our reacting species, but they essentially are unchanged as a result of the chemical reaction. And so we call these spectator ions, and these are not going to be shown in our net ionic equation. So here's our equation here. This is what we would call a molecular equation. This is what we're used to working with, is just kind of an overall description of, in this case, we're combining silver nitrate and potassium chloride, and we get a silver chloride precipitate, and the potassium nitrate will stay dissolved in the water. Okay, the first thing that we want to do is we're going to separate the things that are aqueous, strong electrolytes. We're going to separate those out. And so this second equation here, we would call this our full or just the ionic equation. All right. So this one up here, this is the kind we're used to looking at. That's a molecular equation. And then the full ionic is where we're kind of breaking everything apart. And as you can see, we've got them color-coded here. These are the silver and the chloride. Those are the ions that are actually reacting. They're actually coming together and forming something new. Oops, and my little arrows are not going fully over there, but the potassium and the nitrate, those are what we're going to call spectator ions. As you can see, they are the same on the reactant side as they are on the product side. So when we remove those from the equation, we get the net ionic, which basically just shows us the species that are reacting. Okay, so here's kind of the steps that we just went through. First, you write a balanced equation, call it the molecular equation. Then we want to identify, and this is really important here, the strong and soluble electrolytes. And only those will be dissociated or broken apart in the ionic equation. And then once we have the ionic, we're going to look to see where our spectator ions are. We will cancel those out, and the thing that is left will be the net ionic equation. So here we have an acid-base reaction. This is acetic acid reacting with barium hydroxide, and our products, remember this is just a double displacement reaction, our products are going to be barium acetate and water. And actually, this should be written as liquid water there on that. So we take our strong soluble electrolytes, all right? So we have two. We have the barium hydroxide, all right? Barium hydroxide dissociates into a barium ion and two hydroxides. And then the barium acetate is our other strong and soluble. We get a barium and two acetates, okay? The water is a molecular substance, so it stays the same. The acetic acid is a weak electrolyte, and weak electrolytes we will not dissociate in our ionic equation. All right. Now we have, let's see if we can identify our spectators here. We have barium showing up the same on both sides, and I think that's going to be the only spectator we have. So when we remove our barium, we end up with basically the weak acid reacting with the hydroxide from the barium hydroxide, and that's going to give us, we'll have the acetate ion in there and water. And then if we simplify that down, because as you can see we have 2's in front of everything, we get our net ionic, our simplest net ionic there for that equation. All right, so let's just go back a little bit and make sure we're understanding some of the basic things we have to do to write the net ionics. The first thing is, let's review how we're going to dissociate ions. If I have aluminum sulfate, remember that's going to give me 2 aluminum ions plus 3 sulfate ions. Okay, I put the charge in, and then I also put that they are aqueous. Well, okay, again we have sodium carbonate. Here I'm going to get 2 sodium ions and 1 carbonate. Calcium phosphate, I get 3 calciums. And you should be pausing this, seeing if you can do this ahead of me. Okay, and magnesium borate, I get 3 magnesiums and 2 borates. Let's see. Okay. All right. The thing to remember too when you write your molecular equation is it needs to be balanced. Okay, and there are actually 2 ways that we're going to be balancing equations. And for the precipitation and acid-base equations, we're only going to focus on this first one, materials balance. Here, again, this is what we're used to doing. You're actually balancing the masses on each side of the equation. Okay, same number and type. So that's the balancing we're used to. Then there's also, in some types of reactions, which we're going to talk about in our next session, I believe, some reactions, we actually have a movement of electrons, and so we need to do an electrical balance in those. And we'll talk more about that later, but just be aware that there's, before we can do our net ionic equations, we typically want to have the equation balanced. So if we look at these things, when we mix sodium hydroxide and magnesium chloride, we're going to get, in double displacement, magnesium hydroxide, and that is not a soluble substance that's produced. So it wants us to write the balanced molecular, ionic, and net ionic equations. And so we're going to go through the process with this. Okay, so here is our molecular equation. All right, we need to balance it. And okay. Then to get our ionic, we're looking for our strong soluble electrolytes, and those are going to be dissociated. So strong soluble, as you can see, we have the sodium hydroxide. And again, if it has a coefficient in front of it, you're going to carry that through to the ionic. So see here we have the 2 in front of the sodium hydroxide. So that meant from this I got 2 sodium ions and 2 hydroxide ions. Okay, magnesium chloride, also strong and soluble. The magnesium hydroxide is a precipitate, so it stays as it is. And then sodium chloride, strong and soluble. Again, we had a 2 in front of it, and so that 2 gets carried into our ionic equation. Now we're going to cancel our spectators. Okay. All right. And what's left gives us our net ionic equation. Okay, so essentially combining these things together is producing magnesium hydroxide. That is the chemical reaction. Okay, so let's take a look at some examples here. Oops. Okay, all right. First, I'm going to predict what my products are. And again, when we're doing this, sometimes it's easier to predict those in words. So I have copper chloride, all right, and this copper in here is a +2 copper. So I'm going to have copper 2 chloride, so that's Cu, and then I need 2 chlorines. Okay, that's going to be aqueous. I'll look at my solubility table. That will be aqueous. It's a chloride. And then barium will combine with the sulfate. And if I check the solubility table, barium sulfate is not soluble, so it will be a precipitate. Okay, so looking at this, it is actually balanced as it is. So now I'm going to look and find my strong soluble electrolytes. Well, I have actually 3 of them: the copper sulfate, the barium chloride, and the copper chloride. So to write my ionic, I have Cu and sulfate, the barium, aqueous, and 2 chlorides. Okay, my products are going to be, I'll write them down here, the copper, the 2 chlorides, and the barium sulfate. Stays together because it's a precipitate. Okay, then to get my, let's change my color here. I want to mark out my spectators. All right, I have the copper is the same on both sides. I have the chloride is the same on both sides. So my net equation then is going to be the sulfate ion combining with the barium ion to make a barium sulfate precipitate. Okay, on the remainder of the slides in here, there are 3 equations for you to write the products, write a balanced molecular, and then proceed through to the net ionic equations. And I will pause here because I want you to try these, and then if you open up the PowerPoint next to that's on the website next to this, you can see the final answer, or if you want to, just hit the pause button right now and work on these, and then I will wait just a minute, and then I'll flip to the answers for these 3. But if you're going to work these, go ahead and just hit pause and work on those, and then come back to see the answers.